Hello everyone, I am Dr. Sirajul Fazi. I welcome you in my YouTube channel. Today in this video, I am going to talk about electrochemistry. You know, my friends, the study of the interchange of chemical and electrical energy. We are doing this study in electrochemistry. You also know primarily concerned with two processes, oxidation reactions. And the second one, the generations of an electric current or the use of current to produce chemical change. So first, review of terms, and these terms are important to understand electrochemistry. Oxidation reduction, combinedly we call it redox, involves a transfer of electrons from the reducing agent to oxidizing agent. What is oxidation? Oxidation, loss of electrons and increase in oxidation number. Reductions, gain of electron and decrease in oxidation number. Now, half reactions. The overall reaction is split into two half reactions, one involving oxidation and one reductions. You can see 8H plus MnO4 minus 5Fe2 plus, it gives Mn2 plus 5Fe3 plus and plus 4 water molecules. Fe2 plus is oxidized and MnO4 minus is reduced. Electrons are transferred from Fe2 plus reducing agent to MnO4 minus oxidizing agent. So reductions 8H plus MnO4 minus 5 electron, it gives Mn2 plus 4 water molecules. Oxidation 5Fe2 plus give 5Fe3 plus 5 electron. So balance over all reaction is the sum of the half reactions. Now galvanic cell. What is galvanic cell? You know, a device in which chemical energy is changed to electrical energy. Electrons flow through the wire from reducing agent to oxidizing agent, and ions flow from one compartment to the other through salt bridge or porous disc to keep the net charge zero. Now you can see a schematic of a method to separate the oxidizing and reducing agent of redox reaction. You have MnO4 minus equals H plus equals Fe2 plus equals. You have the wire here. You have different compartment. Now, galvanic cell. You can see salt bridge and porous disc interconnected with the compartments. Now, anode and cathode. The reaction is an electrochemical cell. Occurs at the interface between the electrode and the solution. Interface between the electrode and the solution where the electron transfer occurs. You know, my friend, the electrode compartment in which oxidation occurs is called the anode. The electrode compartment in which reductions occurs is called cathode. So what is cell potential? A galvanic cell consists of an oxidizing agent in one compartment that pulls electrons through a wire from a reducing agent in the other compartment. The pull or driving force on the electron is called the cell potential, or the electromotive force of the cell. You also know, my friend, the unit of electrical potential is the volt, which is defined as 1 joule of work per coulomb of charge transfer. So you can see the reducing agent electrons is going toward the oxidizing agents, and these compartments attach with the porous disc. So anode and cathodes. Anodes releases electrons and cathode accepted electrons. So an electrochemical process involves electron transfer at the interface between the electrode and the solution. Interface means this is electrode and this is the solution. There is an interface. Now you can see digital voltmeters. If you have two solutions, you will read here in voltmeter. Now standard deduction potential. E0 values correspond to reducing half reaction with all solute at 1 m and all gases at 1 atm are called standard reduction potential. So zinc plus copper 2 plus, it gives zinc 2 plus and copper. So copper 2 plus 2 electron, it gives copper. Standard electrode potential 0.34 volt versus SHE, standard hydrogen electrodes. SHE, standard hydrogen electrodes. Zinc 2 plus 2 electrons, it gives zinc. E0 is equal to minus 0.76 volt versus standard electron. So E0 cell is equal to E0 oxidation plus E0 reductions. You will get 1.10 volt. So I repeat, E0 value correspond to reduction half reaction with all solute at 1 m. 1 m and all gases at 1 atm are called standard reduction potential. 1 m and 1 atm, just remember. Now friends, this is the setup of zinc copper galvanic cell. You can see here the copper 2 plus and sulfate 2 minus, zinc 2 plus, sulfate 2 minus. These two are solution. This is 1.0 m solution. Here is also 0.1 m standard solution. So one is cathode, another is anode. The electrons going from anode to cathodes. So here you can see the copper 2 plus taking 2 electrons and zinc 2 plus giving 2 electrons, and is all phenomenon happen on interface. You know, interface is important. So if copper 2 plus get 2 electrons, then it become the copper. If zinc 2 plus release zinc, if release 2 electrons, then zinc 2 plus. That is the importance. Zinc, if release 2 electrons, then it becomes zinc 2 plus, and copper, if take 2 electrons, then copper 2. Now, manipulations for combining half reaction. One of the half reaction must be reversed, which means that the sign of potential for the reverse half reaction also must be reversed. The half reaction must be multiplied by integers as necessary to achieve the balance equation, but the value of E0 is not changed. When a half reaction is multiplied by an integer, a standard reduction potential is an intensive property, and the potential is not multiplied by integers. So line notations. Handy line notation used to describe electrochemical cell. In this notation, anode compartment are listed on the left and the cathode compartment are listed on the right. Separated by double vertical lines indicate salt bridge or porous disk. So in this notation, a phase difference is indicated by a single vertical line. The substance constitute the anode is listed at the far left and the substance constituting the cathode is listed at the far right. Now you can see anode compartment, cathode component, anode compartment iron, you can see the porous disk, you can see the platinum 1m MnO4, 1m H plus, 1m Mn2 plus. So schematic of a galvanic cell. Now complete description of galvanic cell. A complete description of galvanic cell usually include 4 items. First, the eta cell potential, always positive for galvanic cell, and the balanced cell reaction. The second, the direction of electron flow obtained by inspecting the half reaction using the direction that gives a positive E cell. Designations of the anode and cathode, and the nature of each electrode and ions present in each compartment. The chemically inert conductor is required if none of the substances participating in the half reaction is a conducting solid. You can see. Now, EMF and work. You know the driving force, the EMF, is defined in terms of the potential difference in volt between the 2 points in the circuit. A volt represents a joule of work per coulomb of charge transfer. So EMF is equal to potential difference is equal to work divided by charge. So work represents joule and charge coulomb. So 1 joule of work is produced or required depending on the direction when 1 coulomb of charge is transferred between 2 points in the circuit that differ by potential of 1 volt. Now friends, free energy and cell potential. You know del G naught is equal to minus NF E naught. N is the number of moles of electron. F Faraday's 96.485 coulomb per moles of electron. And this equation state that the maximum cell potential is directly related to free energy difference between the reactants and the product in the cell. A positive E cell values correspond to a negative del G value, which is condition for spontaneity. So concentration cell. What is the concentration cell? Cell potential depends on concentration. You know, concentration cell is the cell in which both compartments have the same component but a different concentration. The difference in concentration is the only factor that produces cell potential, and voltage are typically small. So you can see the anode and cathode compartment 0.1 m Ag plus 1 m Ag plus 0.1 m nitrate 1 m nitrate. So porous disc. So concentrated cell that contains silver electrode and aqueous silver nitrate in both the compartments. So what is the Nernst equation? We can calculate the potential of cell in which some or all the components are not in their standard state. So del G is equal to del G naught plus RT ln Q. Del G is equal to minus NFE and del G naught is equal to minus NFE naught. Minus NFE is equal to minus NFE naught plus RT ln Q. Dividing each side by NF, you will get E is equal to E naught minus RT by NF ln Q, and E is equal to E naught minus 0.0592 divided by N log Q. So ion selective electrode. You know, my friends, electrodes that are sensitive to concentration of a particular ions are called ion sensitive electrode. For example, glass electrode for pH measurement. Glass electrode can be made sensitive to such ions as sodium plus, potassium plus and ammonium by changing the compositions of the glass. The pH meter has a standard electrode of known potential. A glass electrode that changes potential depending on the concentration of H plus ion. You know, a potentiometer that measures the potential between the electrodes and electrically converted to pH of the solution. So this is the glass electrode for measurement of pH. You can see the reference solution of dilute hydrochloric acid and silver wire coated with silver electrode and thin walled membrane. Now calculation of equilibrium constants for redox reaction. You know, for a cell at equilibrium, E cell is equal to 0 and Q is equal to K. Nernst equation at 25 degrees Celsius, E is equal to E naught minus 0.0591 divided by N log K, or 0 is equal to E naught minus 0.0591 divided by N log K. So log K is equal to NA E naught divided by 0.091 at 25 degrees Celsius. Now batteries. You know, a battery is a galvanic cell, or more commonly a group of galvanic cells connected in series, where the potential of the individual cell add to give the total battery potential. You know, battery a source of direct current and have become essential source of portable power in our society. So you can see the sulfuric acid electrolyte solution, anode lead grid filled with the spongy lead, and cathode lead grid filled with the spongy PbO2. So one of the 6 cells in a storage battery. So another one, anode zinc inner case, cathode graphite rod, paste of the MnO2, ammonium chloride and carbon, a common dry cell battery. Fuel cell, you know, galvanic cell for which the reactants are continuously supplied H2O to give water, at anode H2OH minus water, and at cathode O2 H2OH minus. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching. Don't forget to share in your circle, friend circle. Thank you.